Hi, everybody. Um, we're here with problem 28 on the review. And yeah, we didn't get to do this one all the way through in class today. So I thought we could record this real quick. And I'm going to use a dog in a hoodie avatar just for the fun of it. Um, so you're going to learn about extrema of functions using a dog. Okay. Um, we've got a landscaping company that's running a pipeline. Okay. I didn't see the R and the B and the P and that thing on this diagram in class. I think we can do a better job of labeling this. We had started this, but anyways, this point up at the top, they've labeled R. Going straight down, they labeled this A. Um, a little bit here, they've labeled a point P. And then all the way over here, we've got the terminal B. And the idea is from the terminal to P is where we're going to go underground. So maybe I'd call this distance G. Um, Over here from the oil rig to the point P, that's where we're going to go over water. Um, and yeah, that point P is slidable. We'll be able to move that towards A or towards B. Um, but maybe one thing to notice on their diagram is that they've highlighted this distance. And so when it says determine how many miles from the terminal the two pipes should meet, this is the distance that they're actually doing. So um, the, I don't know what we call this. We could call this distance D. But I remember that we also labeled this distance as 22 minus um, G on the other one, which I think is a good way to reference things. Um, so let's go ahead and keep it this way. Um, Overall, for the cost function, we were looking to do something like this. The cost of the total project would be the amount of time that you spend underground times 75,000 plus the 195,000 times the amount of time that you spend underwater. I mean, it's distance, not time, but anyways, um, that should be the overall cost. And the idea was we should get this to look like a single variable function rather than a multivariable function of G and W. And so what we did in class is we came up with a description for W, since one of the sides of this right triangle is 22 minus G, and the other side of this triangle would be 36. Setting up the Pythagorean theorem would look like 36 squared plus 22 minus G squared equals W squared. And so this is an equation that can get us to solve for W. We could take the square root of both sides and get the square root of 36 squared plus 22 minus G squared is equal to W. And then we could use that as a substitution into our function so that we could say C of G as an input would be 75,000 G plus 195,000 with our updated version of W. This is going to be gross. Ugh. I'm already regretting putting this on the review. No, just kidding. Um, gonna be fine. Um, that's a good single variable function. And if you were taking a test and you were really pressed for time, um, yikes. Maybe I shouldn't even be telling you this, but this is a bonus video anyway. Um, yeah, let's open up this. Let's go to GeoGebra and let's type in that function that we just had. we don't need that. We're going to call this c of x, and now I'm going to use the variable x instead of g. But if we go 75,000 x plus 195,000 times the square root of 36 squared plus 22 minus x squared. That gives us a cost function. If we go zoom to fit, ooh, you can see that we've got something that looks like a parabola, and oh, hey, we get an extremum there. This is not necessarily the calculus way to do this, but it's the fast way. I mean, we could put it into a calculator and see that we get an extremum there. I'm not going to end the video here because I actually want to use calculus to find this number, but it is possible to do this here. Yeah, x is equal to 7 at a minimum, which is cool. And really, we'd only want to go till x equals 22 as the other one. So this would be, a good possibility if we did, the point 0, c of 0. That's one of the ends of our interval. So that's something that we should consider. We also should consider the one where we go all the way to the end at c equals 22. But what this is saying is we actually find a minimum at 7. And the reason that we do that, we should investigate a little bit further. So yes, technically, this one is a minimum, and we'll only have to spend $8 million. Wow. Okay. So let's go ahead and go back. But if you really needed to get the question fast, graphing it means that you can find the minimum pretty quickly normally. I don't even know, like, is there a minimum? Hmm. Yeah, you probably don't want that. Um, hmm. I wonder what min on an interval is. Man, this really, oh, there we go. That's probably what we want. If we did min of C, oh my gosh, I'm just totally showing you how to cheat the system here. I might have to re-record this. I'm giving away too much. Look at this. Oh, you can find the minimum on an interval. Ugh, that's great. I'm so happy I did that. All right, so if we were going to do this the calculus way, we would take a first derivative. Now that we have this in terms of one variable, we go 75,000 plus 195,000 times the derivative of this mess. So we'll have 1 over 2 times the square root of everything that's underneath. And then we'll multiply by the derivative of the inside. The derivative of the inside, the 36 is not going to matter much. But the 22 minus g will. So taking the derivative there, it would be it would be 2 times 22 minus g to the first power. And then there would be another chain rule on this smaller function where we need to multiply by -1 because that's the coefficient on g. So yeah, really we've got 75,000 plus 195,000 times, all right, so this is a negative number. So -2 times negative minus g gives us 2g. And then we'll also be multiplying by negative 44. That's the 22 times 2 times negative 1. Cool. And the idea is if we then set this equal to 0, we could continue to solve for critical points. That would make this whole thing turn to 0. So, yikes. We could go ahead and maybe throw all of that fraction onto the left-hand side so that we get rid of the negative part. We could probably cancel this 2 and this 2, and that would be okay. So let's go ahead. Oh man, let's go 195,000 times g times 44 on the top, and square root of 36 squared. I don't know what 36 squared is. Um, I mean, we could, yeah, we probably want to expand that out. Oh my goodness. Um, yeah, all right. Let's go. I'm I'm sorry. It's the afternoon. What's 36 squared? Ah, 676. Wonderful. And then what's 22 squared while we're at it? That one I should be able to do. 44. Oh, for shame. Okay. Um, cool. So 676 plus, let's go g squared. Yikes, I'm gonna run out of room. G squared minus 44g plus the 22, the 484. Boom. Yikes. Okay. So we're doing okay, but now we should multiply both sides by all of that square root junk. So that we get 195,000 g times 44 is equal to 75,000 times the square root of, ooh, here, let's add 676 to 484. Seriously, I don't want to do that. 676 to 484. It's going to be adding 1,160. So we get g squared minus 44g plus 1,160. Cool. Oh, I should divide both sides by the 7,500. Okay, so let's do this. What's 195 divided by 75? 195 divided by 75. You guys don't want to watch this. This is horrible. 2.6. Okay, 13 fifths. Great. All right, so we're gonna, yeah, open this up. I'm bringing the 75,000 over so that we get 13 fifths g times 44 is equal to the square root nonsense. And then we square both sides so that, I don't know, yeah, we've got 13 squared times 44 squared over 5 squared times g squared equals g squared minus 44g plus 1160. Whoa. And then we keep going and figuring this out. All right, we're running out of room. Let's make it green and go up here. That looks huge. All right, let's do this. 13 times 44 squared, and then divided by 5 squared. Well, that's a wonderful fraction. And then we're gonna, you know, do that number minus 1 to be able to subtract off the g squared on the other side. 327,159. All right, great. 327,159 over 25. This is awful. G squared. And then plus 44g, and then minus 1,160 equals 0. Right. All right. So this is where I am. And, at this point, you might be thinking, wow, maybe I should have done this before recording it to make sure that I know how this is going to work out. But that's pretty gross. Let's go ahead and throw that into the quadratic formula. I mean, that's what we need to do is quadratic formula. X equals, or I guess in this case, G equals negative B, negative 44, plus or minus the square root of b squared, so 44 squared minus 4ac fraction times negative 60, great, all over 2a, which is 2 times that crazy fraction. Let's go ahead and utilize the calculator to get this done because it's kind of crazy right now. I'm going to go ahead and type in, there's our fraction, times g squared. G has not been utilized yet, right? Yes. Okay. Oh, but we don't want, okay, hold up. We don't want x. We want x squared for our variable. Okay, so there's that fraction times x squared plus 44 times x minus 1,160. So here we get a nice quadratic. And the idea is, does this intersect at the right spot? No, not at all. What have I done? You probably have already seen it. All right, pause break. I'll be back. Okay, after some looking, I figured out one of my mistakes was when I put 36 squared into the calculator, it was actually 26 squared. So I need to go back here and change this. That is actually 1,296. And I need to go back here and fix everything. Maybe I should just re-record all of this, but good grief, I don't want to. All right, so I'm gonna do this in a new color. Let's make this bright green. So this is 1,276. Is that what I said? Great. Let's look at this again. No, 1,296. Goodness. Okay. And then we're going to need to do this eventually. 1,296 plus 44, 1,780. Okay. That's going to make things different along the way. Let's go ahead, go back here, fix that, and then we fix this over here. 1780. Now I'm sorry, I'm tripping. Yeah, 1780. There we go. Let's go 1780 here and 1780 here. I'm hoping that this makes that awful fraction a little bit better. Does it? Yes. Instead of, yeah, we're going to subtract off more, right? No, no, it just makes C bigger. Okay. So this one ended up being 1,780, and this ends up being negative 1,780. Is this big enough to make a difference? Let's find out. All right, so let's go back to that graph because we were using this graph, as a way to do this. If we subtract 1,780, wait, seriously? That changed it like not at all. Okay, breathe in, breathe out. There's still something I messed up. I will be back. All right. Well, I see something else now. Um, I don't know what I was doing when I was multiplying over here, but yeah, if we look back at this step, I should have multiplied -2 times 22 minus g. But in the next thing over here, I totally messed that up. I split it into two factors. That's just not right. Let me go ahead and okay. Let's do this. I'm going to make this in bright green as well to show another place where I made a mistake. Um, this should just be 2g and then minus 44. That should still be one factor. Okay. And if we wanted to cancel top and bottom kind of a thing, we could cancel a factor of 2 with a factor of 2 here so that it's g minus 22 on top. But it's g minus 22 on top. It's not g times 44. That's ridiculous. Okay. That was wrong. I'm sorry that I didn't see that earlier. I'm gonna have to go through and again fix that stuff. So what? Hopefully, though, this is gonna make things, nicer. So this is ridiculous. This is ridiculous. That is where we got that gigantic fraction. Um, okay. G minus 22 is just chilling. G minus 22 is just chilling. And then we're going to square everything. So we get, 13 squared over 5 squared times g minus 22 squared. But that's not awful. It's going to be, weird, but it's not going to be as bad. All right. Let's go ahead. Let's erase all of this nonsense and we'll just keep going. Okay. Let's see what we can do now. Okay, 13 squared. All right, so this is 169 over 25 times, let's do g squared minus 44g plus 484. Okay. With that, yeah, g minus 22 thing going on. All right. And that equals the other side, g squared minus 44g plus 1,780. Okay. All right, so let's take off 25 from 169 to get our coefficient on g squared. That'll be 144 over 25 g squared. This is looking more promising. Then we've got to do, oh, whatever that is. Oh, I guess we're doing the same thing. We've got 140. Yeah, so I guess this is going to be, oh no, we're adding. No, okay. All right, let's just write this out so that we don't make too much of a mess. 169 over 25 times 44 g. And then we are going to add 44g from the right-hand side. And then we've got 169 over 25 times 44 minus the 1,780 that we had before. Oh my goodness. And now you can't even see it. Let's bring this over. Scale it down a little. Goodness gracious. Oh, it's so bad, you guys. I'm not sure that this video is going to be entertaining. Okay. Unless you just like seeing me suffer, which, I don't blame you. Okay. We've got 144 out of 25 g squared. Then we are adding on 25. So it is going to be the opposite sign. I think it's still going to be, if we combine these two terms together, it'll be whatever. It'll be minus 144 over 25 times 44g. Because that's just taking 25/25ths of 44g off. Okay. And then, this will be some constant number. All right, let's open up the calculator and see what these things are. Let's do, oh my, all right, here. And, all right. So let's not do this fraction. This fraction should be 144 over 25. And then this should be 144 over 25 times 44. And then this should be that, but plus 169 over 25 times 44. Oh no. It's not any better. It's possibly worse. What have I done? All right, I've gone off the rails. I'm pausing, and I'll see you soon. Okay, we've reached a new depth of pain. Hey, remember when I made that mistake up here in the red box? And then I tried to fix it with the green stuff? It was okay right here. But what I had forgotten is that I actually brought this over to the other side. And so this part should no longer read g minus 22. It's the opposite of that. And you know what? We could throw a negative sign in there right now. I mean, we could throw a negative sign on the outside. But what we should just do is just change the order. All right, so since this is a new level, we're going to change the color to highlight our new mistake or happy accident. No, it's not happy anymore. So that makes this polynomial exactly the same. And that doesn't solve anything. Give me a second. Okay, y'all, I'm back. And the comedy of errors continues. Okay, the idea here is I accidentally typed a plus sign when there should have been a minus sign. So on this part of it, this should be a minus instead of a plus. So when I did this, this should be a minus. And I typed in 196 instead of 169. And that's a problem as well. And then we have a g. This function, I kid you not, it has a root at 7. Like this one. Here I did it again. I put this in so that I didn't combine stuff and make more errors there. This is just the left-hand side of the equation that I had minus the right-hand side of the equation. And so now these two things are equal instead of being different. If you wanted to see it in a nice, kind of simplified slash expanded form, these are the numbers that you would throw into the quadratic formula. I know that they're not great. Or if you wanted it to be simplified in terms of being factored, there's going to be one root over here at 37 and another root at 7. So this one's actually factorable. You would just have a 144 out of 25 at the front, and then you've got an x minus 37 term and an x minus 7 term. So let's go ahead and, pretend like I could do that by hand. All right. Up to this stage, I think we were good. I made a mistake typing that one wrong and typing that in incorrectly as well. So yeah. I think the best version of this, let's go ahead and just put this over to this side, and then we'll bring this one here. I think the best version of this is the one where we pull out that 144 over 25. I know that it's not in a great spot right now, but yeah, if we pull that out from every term, that g squared comes out nicely. These two, remember that these two simplify to be a minus 144 over 25. So here we're going to be a minus 44g. And then the one over on the right-hand side, it's going to be whatever 37 times 7 is. Let's do that real quick. 37 times 7, 259. Excellent. So this part to the right should work out to be 259 once you factor out a 144 out of 25 over 25. And then, yeah, this is the way that it should reduce. And I'm sorry, this was completely gross. Apparently, 259 is 37 times 7. And this one is the only one that makes sense in the context of our problem. G equals 7 is the only one that makes sense because the tract of land that we were working with, let's go ahead and get this back into focus. Okay. Um, yeah, this is only 22 long. Um, so yeah. Uh, so how many miles away from the terminal? The answer is G. Or sorry, the answer is 7. This G is equal to 7, and I know that it is, I don't know, surprisingly small. That this distance, let's see, pink, that this distance is 7, and this distance is 22 minus 7, so that's 15. Wow. So, my drawing, not to scale, but the math that gets us there is okay. Um, I'm not going to have you do this on the test. That is way too crazy in terms of the things that you have to multiply together and not make a bunch of sign mistakes along the way. Um, all right, well, we got there. And if you're just joining us, welcome. The main idea is, um, yeah, we come up with a cost function. We find a way to write W in terms of the G length down here. We use the Pythagorean theorem. Then, once we have everything as a single variable function, we can take the derivative with respect to that variable, do things correctly, set that equal to 0 to find a critical point, and the critical point that is within our domain, we're able to make G go from 0 to 22. The only thing that's there is G equals 7. And so to really finish this problem out, what we would do is end up evaluating, let's go with pink. This is a good one. We would calculate C of 0 as one of the endpoints. We would calculate C of 7, and we'd calculate C of 22 as the other endpoint. And then, yeah, we already did that on that graph, but the C of 7 is the minimum. Wow. Yeah, and it's only like 8,130,000. Yeah, 8,130,000 dollars. The 01 is 8227059. So that's more expensive. And this one's 8670000. And so, I mean, we just saved what, about $90,000 from going from the first version where we just go all water. Look at us. We're being frugal. I'm sorry that this was so much pain. In hindsight, maybe this one was too painful for the review. It's not bad. It's just the minutia that if you get it wrong, it vexes you for a long time. All right, thank you for listening. This one's not going to be on the test, but the overall idea of optimizing things will be. All right, we'll see you Wednesday. Bye. All right.